Hello, it's here in this video. I'm going to talk about a stable multivibrator, how to design a circuit and how to work on a stable multivibrator, monostable multivibrator, and a bistable multivibrator. This one is bistable. It is a bistable multivibrator. Okay, let's know. Before this, we need to know about stable multivibrator, how this stable multivibrator works. Okay, here we need a 555 timer IC. Okay, 555 timer IC is needed, and it have 8 legs. Okay, 4 leg in one side and 4 leg in the other side, and this IC should be connected in such a way that 8 and 4 terminals should be connected, and should be given plus 5 volt. Okay, we can simply do that. 8 and 4 terminals should be connected with the jumper wire, and we need to give plus 5 volt. And again, between 8 and 7 we need to give only 10 kilo ohm. Okay, it is written 100 here, but 100 is for another need. We give only 10 kilo ohm. Ra will be 10 kilo ohm, or we can simply say this as a R1 and R2. Okay, this R1 or RA should be 10 kilo ohm, and 8 and 7 should be connected by a 10 kilo ohm resistor, and again 7 and 6 will be connected by a 1 kilo ohm resistor. Okay, 7 and 6 should be connected by a 1 kilo ohm resistor. We need to keep just one resistor between 7 and 6. Okay, in a breadboard we will keep that resistor in 7 and 6 number terminal. Again, this 6 and 2 will be connected with the jumper wire, and from this 2 we can use either 0.1 microfarad or 0.01 microfarad resistor or capacitor, and we need to give a ground. Okay, up to here a circuit is made, and from this 1 number terminal we need to give a ground to 1 number terminal, and from this 5 number terminal we will connect a capacitor of 0.01 microfarad, that is 103, and we'll connect it to the ground, and from this 3 number terminal we'll connect it to the output of a operational amplifier. We'll see output in a amplifier. Okay, and here we have given plus 5 volt. We have connected these all. Then if we connect this to the operational amplifier, and directly we may not see wave, we need to operate it, we need to calibrate this operational amplifier, we need to check in a certain voltage whether it is possible or not. So this operational amplifier should show such a data such that there should be some point, for some time interval it should show some high voltage, and for some time interval it should show low voltage, and again high and again low. Such type of voltage, if it is seen in an oscilloscope, then our stable multivibrator is being ready. Okay, we should see such type of output in a oscilloscope. If we connect this more properly, then we can see it very much clearly. So this upper one time period can be considered as a T1, and down one time period can be considered as a T2. Okay, T2 and T1, small letter T2 and T1, and the total T can be said that it is a sum of T1 and T2. T is the sum of T1 and T2. The total T is the sum of T1 and T2. We can say this two things. So there is formula to calculate a time interval of T1, that is 0.693 RA plus RBC. Let's check it once. 0.693 RA plus RBC. This is correct. Just a minute, I'm checking it. Sorry for this. Okay. T1, that is small letter T1. This T1 terminal can be, we can get this time interval 0.693 R1 plus R2 C. Okay, we can take a capacitor, any one capacitor 0.1 1 or 0.01, whatever we keep over here. Okay, with that we can connect this 0.693 RA plus RBC, and T2 terminal can be taken as 0.693 RBC. We'll take this one capacitor. Okay, and we can take this theoretical value of time period, and we need to check it whether this theoretical value and experimental value of time period match or not. Okay, this is the thing to be checked. It is very simple. If we connect this circuit, we give a power supply, and be sure that all the terminal, all the points should be properly connected on that breadboard, and we can see this graph, this type of graph obviously in a oscilloscope. Okay, and from here we need to take out a duty cycle. For a formula of duty cycle, I would like to write here. Okay, the formula for duty cycle is small letter t1 by capital letter T into 100, capital T into 100%, to 100%. It is the duty cycle of this transformer. Okay, it is a practical value of for the duty cycle we can take out by this way, and theoretical value of duty cycle can be taken by the formula RA plus RB or R1 plus R2, same value. Okay, R1 means RA, R1 plus R2, R2 divided by R1 plus R2 divided by 2R2 into 100%. 2R2 into 100%, same thing should be here. Okay, into 100%. So by this way we can take out the curve, and we can estimate a duty cycle, we can estimate a time period for different type of thing in Astable multivibrator, and till this Astable multivibrator will be completed. Now if we go to monostable multivibrator, okay, monostable multivibrator is also the same type of device. We need a 555 timer over here. Here 555 timer. One thing I want to say that if you want to make monostable multivibrator, then we need to make this Astable multivibrator previously, because its output will give trigger in such type of multivibrator. Okay, monostable. In one breadboard, we can design this monostable or stable board amplifier or sorry multivibrator timer in same breadboard. Okay, here what we'll do, we'll connect 8 and 4, give 5 volt, same like before, and 8 and 7 will be connected with 10 kilo ohm. Okay, we can connect 10 kilo ohm, 8 and 7. Okay, and 7 and 6 will be joint, and from 6 we can use either 0.1 or 0.01. We'll connect capacitor and we'll give it to the ground. Again, this 1 number terminal will be ground like before. 5 number terminal will be given capacitor and ground it. Okay, and from this 3 number terminal we give a output to a operational amplifier. But where is the input here? We need to give signal as an input, trigger as an input. So for this, we'll connect this output of Astable to input of monostable, because it works as a clock. Okay? We know that Astable multivibrator gives T2 time interval for a short period of time. So for this, we need to do little bit change in Astable multivibrator. What we need to do is we just replace this IC 10 kilo ohm IC to 100 kilo ohm. Why? Because if you want to give such type of input to monostable, then we need to convert that RE into 100 kilo ohm. If we convert this into 100 kilo ohm, then this output will be connected to the trigger of this monostable multivibrator, and this multivibrator works properly. Okay. We'll give a very low trigger. I want to draw here. Okay. Triggers should be for a very short interval of time. This low input should be very short interval of time. Low trigger input will be given, and from here, if we connect to operational amplifier, then what we can see is it is an input trigger. Okay, input trigger we can see because we need to connect one probe of oscilloscope over here and another probe of oscilloscope over here. So input trigger is this, then the output trigger will be like this. Okay, output of this monostable multivibrator will be like this. It is in such a way that whenever the trigger is down, the output voltage will be 1. And for after some time, this output voltage automatically decreases to 0. Okay, we can write here this 1 and this 0. Again, it will be 0. And it waits for another trigger to be output, high output. Okay, for the another trigger, it can be high output. Okay, I hope I'm making clear. I want to say once again, if the trigger will be supplied by this. If this timer gives a low trigger input, then the output of this monostable multivibrator increases along with this trigger. It works as a clock. Okay, output increases, and after some time the output decreases. Again, it waits for another low input clock, and again the output increases. In such a way, the monostable multivibrator can be drawn. We need to make this trigger and output in our tracing paper. Here we need to make this in a tracing paper, and we can complete this monostable multivibrator. Now, how to connect this bistable multivibrator? How to see this type of curve? Uh, okay, how to see this type of curve we'll discuss now. Now we'll remove this monostable multivibrator from our breadboard, but we will not remove this. Same thing happens over here. 8 and 4 will be connected with the 5 volt, and 8 and 7, sorry, there is no any connection with the 7. No connection, maybe this NC means no connection. And what we'll do, we'll supply 10 kilo ohm resistance over here between 8 and 6, and this 6 and 2 will be connected. And from here, we'll keep one capacitor, 0.1 microfarad, 104, and we'll supply input. That is, this 3 number input will be supplied over here now. Okay. This is the arrow. Okay. Input is supplied over here. And what happens, we'll give trigger from here. And again, we'll keep here another resistor of same 10 kilo ohm, and we'll ground it. 1 number terminal will be ground, 5 number terminal will be ground, okay, and 3 number will can take out output. So if we see output from here, from 3 number terminal, then we can get this type of output. Again, like before, for a low input, okay, we can give for a low clock from a stable multivibrator. Okay, it is the input one. As soon as the clock becomes low, then what happens? The output remains high for some time. Again, it can be low, and it waits for another clock. In another clock, in this clock, again the output will be high, and it waits for another clock. If the another clock is again low, then the output will be high from here. Okay, if this clock is low, output will be high from here. Okay, by this way this works. Okay, the main example of this type of multivibrator is a doorbell. Okay, if we press the bell, and then this input will be triggered, and for some time the bell rings, and for another trigger, if the another trigger comes, then again the bell rings. By this way we can talk about this multivibrator. Now, how can we see this charging and discharging of capacitor from this terminal? If you connect one terminal to this one, that is same input for all. Okay, one thing I want to say, why we for the input in another terminal, why we change it to 100 kilo ohm? If we change it to 100 kilo ohm, then this T2 time interval will be very less, so that for a less interval of time we can give an input. So for that we convert RA into 100 kilo ohm. So if we check a voltage from here or from here, okay, from this terminal, if we check a voltage, then we can see this capacitor is being charged and discharged. Okay, charging and discharging of capacitor can be seen. Okay, by this way we need to trace a curve with the input. Okay, input one, we'll see this capacitor. After that we will see this. Okay, at first we'll connect oscilloscope here, and we can at first we can connect oscilloscope here and here. Okay, here and here we can connect oscilloscope. I want to change the color of my pen. mm, here how to perform this type of core. For this type, we'll take an input from here and output from here. We'll get this two. And in same type of same tracing paper, input already we have, and now we'll remove this oscilloscope from this point and we'll connect to oscilloscope over here, and from that same place we'll connect, design this output curve. So up to here, it is the working mechanism. It is the um, ideas how we can perform practical in our physics laboratory. So if you find this videos is informative, please let me know. Okay, please comment wherever you can. If you know, you can just text me uh, and say something uh, about this video. And thank you very much for listening, those who are listening over here. Okay, thank you very much. Goodbye. uh, Take care. Bye bye.